Hello, we're going to go over the Ferris wheel problem today. This is going to be part of your sync meet assignment for this week, and it's also the same or very similar to the question number 4 on the homework number 3, which is the beginning trig applications. So if you're having problems with that question, this video should help you out as well. So what we're going to do first is we're going to find the maximum, minimum, middle, amplitude, period, and shift. Then we're going to write an equation and answer the questions. So the first thing I want to do is find the maximum. So let's read through the question. It starts off by saying that the London Eye is a huge Ferris wheel with a diameter of 135 meters in London, England, which completes one rotation every 50 minutes. Riders board a platform 3 meters above the ground, so the bottom of the wheel is 3 meters off the ground. So let's start off by finding the maximum and the minimum. Well, the minimum is told to us in the question. The minimum is just going to be 3 meters because that's how low it is when you get on. To find the maximum, all I'm going to do is take the minimum, which is 3, and add that to the diameter, which is 135. So if we kind of look down here at the drawing, this would be 3, and then this part here would be 135, so I would have to add those together, and that will give me 138. Whoops, let me get that right, 138. Now, to find the middle is just the average of the maximum and minimum. So, to find the middle, I'm just going to add the maximum plus the minimum, and then divide that by 2. So that's going to be 138 plus 3 divided by 2. And when you do that, you're going to end up with 70.5. So my middle is 70.5. Now, the amplitude. Remember, the amplitude is just how far does it go from the middle to the maximum and the minimum. So the middle of this Ferris wheel is going to be right here. So it will go, this distance is the same thing as the amplitude. And I can find that just by taking the maximum, which is 138, and subtracting the middle, which is 70.5. So if you do 138 minus 70.5, you get 67.5, and that's the amplitude. Now, the period is just how long does it take to go all the way around once. So if I start here and go all the way around, in the question it tells us every 50 minutes. So the period is 50. Now the shift. Well, we can write this equation without a shift, and that's probably the easiest way to do it. So what I'm going to do is I'm just going to say 0 here, and I'm going to write the equation without the shift. So what I'm going to do is we're going to say that time t equals 0 starts when you get on the ride. So when you get on the ride, you're at the minimum. If you're at the minimum, that means it's going to be a cosine equation, and it's going to be negative. So we start with y equals my middle, 70.5, minus, because it starts at a minimum, so minus 67.5, which is the amplitude, times the cosine. Now we need to find the b value. B is just 2 pi divided by the period, and so that will just be pi over 25. So cosine of pi over 25, and then times x. So that's going to be my equation. So I'll see if I can fit it in here. Times x. Okay, now the last two questions are going to ask us questions about this. Excuse me. It says, what is the rider's height off the ground 20 minutes after they board? Well, all I need to do is put 20 in place of x and solve. So in my calculator, to do this question, I'm just going to go 70.5 minus 67.5 times the cosine of pi over 25 times 20, because it's 20 minutes. Put that all in your calculator, and when you do that, you should end up with 125.1 when you round it to the nearest tenth. Now, it's a little bit trickier to find how many minutes after they board the rider's 40 meters. Now, remember that there's going to be two spots where the rider is 40 meters. There's going to be one spot over here where the rider is 40 meters and one spot over here where the rider is 40 meters. So we have to find both those times. So my equation will look like this. 40 equals 70.5 minus 67.5 times the cosine of pi over 25 times x. And we want to solve for x. So to start, subtract 70.5, subtract 70.5, and that's going to give me 30.5 is equal to negative 67.5 times the cosine of pi over 25 times x. Now I'm going to have to divide by negative 67.5. And this should be a negative 30 there. So that cancels out. Negative over negative makes this positive. And I'm not actually going to put it in my calculator yet. I'm going to do the inverse cosine of that fraction. So when you do the inverse cosine of 30.5 divided by 67.5 in your calculator, you're going to end up with a number that is equal to about 1.01. I'm sorry, let me back that up just a little bit here. 1.10956 is what I'm going to put it at. Now, that is what the inverse cosine equals. So that equals what was after my cosine before. So that equals this. So that's pi over 25 times x. So to solve this, I'm going to multiply by the reciprocal on both sides. So if I multiply both sides by 25 over pi and multiply this side by 25 over pi, that will give me an answer of 8.8 when you round to the nearest tenth. So that's the first time. Now, I'm going to have to erase a couple of things here so I have some more room to find the next one. So I'm going to just erase what I did up here, and now we'll find the second spot. Well, to find the second spot, what you do is, all you do is you take 2 pi, and then you just subtract the inverse cosine of 30.5 divided by 67.5. So it's this part here is the same. The cosine, inverse cosine part's the same. I have to take 2 minus that and set it equal to my pi over 25 times x. Now, when you do that on this side here, you get 5.181229 is equal to pi over 25 times x. And then you just multiply both sides by 25 over pi and 25 over pi. And when you do that, you should end up with x is equal to 41.2, which is my other answer.